Material from section 1.3. Really what I want to get at here is this average rate of change here, this AROC that you learned at 1.3. Turns out that's what calculus is essentially. When you take a calculus class, the very first thing you will be doing is going back to average rate of change and realizing how that can be a lot more powerful than it was in the section when you learned it 1.3 in your pre-calculus class. So here's a quick little preview of what you'll see in calculus because I think it's interesting. A pre-calculus question is to give you a function like f of x equals x squared and to ask you, so here's pre-calc, I could ask you to find the average rate of change on the interval from, I don't know, 1 to 3. Sure. And you could do that for any function, for this function f that's pictured here, because you're an expert with average rate of change and you say, well, average rate of change is the difference in the two y coordinates over the difference in the two x coordinates. In other words, f of x2 minus f of x1 divided by x2 minus x1. And so the two x coordinates are given to me, they're 1 and 3. So I'm going to call 3x2 and 1x1 to keep this positive, although it doesn't really matter which you call which. And then f of x2 would just be what comes out of this function when I put 3 in. Well, 3 squared is 9, so 9 would come out. What comes out of this function when I put 1, x1, which is 1 in? 1 squared is 1. So I would say this is what, 8 divided by 2, which is 4. That's a pre-calc question. It asks you to find the average rate of change and it gives you an interval. It gives you two different x values. A calculus question is, this is not how it's going to be asked in calculus, but essentially is find the average rate of change on 1, 1. Well, wait, what? The two x coordinates are the same. They're both 1s. Find the average rate of change. That's what's pictured right here. Right? You're just given one point where the x coordinate is 1, and coincidentally the y coordinate is also 1 here. But you're given the same point twice, and you're asked to use the average rate of change formula. And so go ahead and try it. I'll wait. Actually, I won't wait because it won't go well. Right? If x1 is 1 and x2 is 1, then you'll have 1 minus 1 is 0. And you may remember from a previous math class, or this math class, that dividing by 0 is a bad thing. You can't get any information when you divide by 0. So to answer this question in calculus, find f prime of 1. This is find the derivative to this function f of x when x equals 1. It's really asking you find the slope of this red line right here. And the way you'll do it is with the average rate of change. But you'll get really clever about it. You'll say that x, let's see, how should I call these? x1 is 1. That's this right here. But x2 is not 1. It's something totally different. Give it a name. I don't know, maybe a. Wait, A? What do you mean? Well, don't worry. Later on, I'm going to change all the A's into 1s. So really, I am finding the average change from 1 to 1. Because later on, I'm going to call A's 1s. But if I call A's 1s right now, I'm saying find the average rate of change from 1 to 1. And this formula is not going to like that, right? I'm going to divide by 0 because 1 minus 1 is just 0. So I got to trick this formula. It'd be like, no, I'm not dividing by 0. Don't worry about that. I'm doing 1 minus A down on the bottom, not 1 minus 1. So let's set this up. What if you were to do the average rate of change formula with these two values? It would be a little bit weird. The average rate of change would be f of x2. Well, that's what comes out of this function when you put x2 in it. And x2 is a, so I guess what would come out would be a squared. Okay. F of x1, well, that's a little bit easier. x1 is just 1 and 1 squared is 1. And then down on the bottom here, x2 is a, x1 is 1. And so this is the average rate of change. It's a squared minus 1 over a minus 1. But note that I cannot change all the a's into 1s right now, because if I did it right now, I'd get 0 divided by 0, which wouldn't give me any information. But what's really nice is I can cancel out this a minus 1. If you're really good at factoring, you might look at this thing and immediately recognize the difference of squares. That a squared minus 1 is a minus 1 times a plus 1. And through the magic of algebra, I can cancel out these two a minus 1s and get a plus 1 here. Okay, there's all sorts of shady math going on right here. Really, you shouldn't cancel out anything when you have a variable, especially not later on. I'm going to change all the a's into 1s, and I shouldn't cancel 0 divided by 0. There's something a little bit shady going on here. And calculus takes care of all that stuff by introducing a concept called limits. But that's okay, as long as you don't mind this algebra that I just did right here. What I've just figured out is the average rate of change from 1 to a is a plus 1. And so if I make this value of a right here 1, I can figure out the average rate of change from 1 to 1. Right? It would just be 1 plus 1. I'm changing this a in the answer into 1, which is 2. In other words, this red line right here has a slope of 2. The answer to f prime of 1 is 2. The way it'll be worded in calculus is you'll be asked to find the slope of the tangent line to this function at the point 1. But really all you're being asked is find the average rate of change from 1 to 1. And what you got to know is trick the math. Don't make x1 and x2 both 1s right now. Make one of them 1 and call the other one a. And just trick the math. Because if you make them both 1s at the start, you're dividing by 0, and that's bad. But what's really nice, if you call one of them 1, you can do some cancelization here and get something that you can now change all your a's into 1s. And you'll make these concepts a lot more precise when you're in a calculus class. But for now, you can do it just like this. And what's kind of interesting is you can figure out, you know what, I'm not even going to do this second one. Let's not get too overboard with our calculus. This is calculus, what we just did right here. And you're like, wait, so calculus is always finding the slope of the tangent line to this curve f of x equals x squared? No. That's what's different. This function can be whatever the hell you want it to be. It can be x cubed or the square root of x or some crazy function that takes a half an hour to write. It can be anything you want. And you'll plug it into essentially an average rate of change formula where the 2 points are the exact same value. But you won't immediately admit to your formula that the 2 points are the same. You'll hide the fact that the 2 points are the same by calling the other one some letter. And then you'll do some sort of clever algebra, which in this case wasn't too bad with the algebra to cancel out this a minus 1. But it turns out the algebra can get really, really complex in how you cancel out the thing that would make you divide by 0. And then once you cancel out that thing that makes you divide by 0, then you can admit to the formula, yeah, that a all along, that was just a 1. Don't worry about it. That was a 1, because now I'm not dividing by 0 anymore. What you'll end up doing in calculus is you'll quickly realize that this algebra gets really, really hard depending on the function. So you'll spend the majority of the class learning tricks and shortcuts so you don't have to rely on this algebra, which is what you'll be doing. But it's kind of cool that you can do algebra just by using average rate of change and some sort of, I don't know, shady math going on here, kind of a trick up my sleeve. Like, yeah, it's 1, but don't worry, it's not really 1, at least not for now. I don't know, I think this stuff is kind of cool. I'll stop this video here, but the point I want to make is that if you get a math teacher that gets really excited about average rate of change, might seem like a boring topic in pre-calculus, but it's actually a super interesting topic that all of Calculus 1 is devoted to.